The first thing we need to be able to do in C3 is to simplify rational expressions. That is to say, be able to deal with fractions. So we're all happy if we have something like this, 15 over 6, then this is equal to 5 over 2. And we know this because as long as we divide the top and the bottom by the same number, then our fraction stays the same. To get from 15 to 5 we divide it by 3, from 6 to 2 we divide it by 3. Therefore the two fractions are the same. But we need to consider what happens if we don't have a constant in our numerator and denominator. So if we had something like this, we have 7x squared over x. Now, as long as we divide the top and the bottom by the same non-zero value, then our fraction will remain the same. So we can, just as easily, divide the top and bottom of this fraction by x. So x divided by x is 1. X squared divided by x, as we learned in C1, is just x. So this is, overall, just equal to 7x. It's important to remember that we can only cancel down if everything in the numerator is multiplied together and everything in the denominator is multiplied together. So, for example, if we had the following, 3x plus 7 all over x, we can't just cancel these x's, because the numerator isn't the product of things all multiplied together. We have the 7 added on. The next sort of question you might get involves something like this, where you can't immediately just divide the top and bottom by the same value. What we're required to do is to factorise first of all. So, if we take a factor of x out of the numerator, we get x multiplied by x plus 2, all divided by x plus 2, and now we're able to divide top and bottom by the same value, in this case x plus 2. So they cancel, and we're just left with x as our final answer. It's important to recall all the different ways which we've learnt to factorise functions before, because they can all come up when we're trying to simplify a rational expression. For example, if we had x squared minus 9 over x plus 3, then it helps us to remember the difference of two squares. Here we have x squared minus 3 squared, and that is equal just to x plus 3 multiplied by x minus 3. That's all over x plus 3, so we can just cancel that with that, and then we're left with x minus 3 as our final answer. We can also be expected to factorise quadratics, either in the numerator, the denominator, or, in this case, both. So here we have x squared plus 2x minus 3, which would be equal to x plus 3 multiplied by x minus 1. And the denominator, we have x squared plus 5x plus 6, which is equal to x plus 3 multiplied by x plus 2. And we can check this because 3 times minus 1 is minus 3, 3 minus 1 is 2, 3 times 2 is 6, and 3 plus 2 is 5. So we know this bit's correct. And now all we have to do is divide top and bottom by x plus 3. So that goes away, and we're left with x minus 1 all over x plus 2. And that would be our final answer. Also, it's important to note that when we say we want something fully simplified, that means we don't really want to have fractions inside fractions, nor decimals inside fractions. So, in order to simplify this, we're not going to divide by anything. In fact, we're going to have to multiply. So we need to ask ourselves, what do we need to multiply half by to give us a whole number? Well, it'll be any multiple of 2. And what do we need to multiply a third by to give us a whole number? Any multiple of 3. So we're looking to multiply the top and bottom by the same number, so this needs to be a multiple of 2 and 3. So we're going to try multiplying by 6, the lowest multiple of both 2 and 3. So if we multiply by 6, we get 6 x plus a half all over 6 x plus a third. And now all we have to do is expand our brackets. So on the numerator we have 6x plus a half times 6 is 3. The denominator 6x a third times 6 is a half, is 2, sorry. So our final answer is 6x plus 3 over 6x plus 2. Now we can recall that when we want to add fractions together, we can only do so if the denominators of the two fractions are the same. So if we wanted to add these two fractions together, 2 upon x plus 3 upon y, we need to make their denominators the same, and we do this by multiplying the numerator and denominator of the first fraction by something, the numerator and denominator of the second fraction by something else, such that their denominator will be the same. So just looking at them, I want both of their denominators to be equal to xy, so we can see that we need to multiply the denominator of the first one by y, which means we must also do the same to the numerator, and we must multiply the denominator of the second one by x, which we must also do to its numerator. So this is equal to y times 2 upon xy plus x times 3 upon xy. So now, because they have the same denominator, we can just add them up. So we have 2y here plus 3x, and this is all over xy. Remember, when we're adding fractions, the denominator doesn't change. So that's our answer to the original question. 2 upon x plus 3 upon y is equal to 2y plus 3x all upon xy. So that's about all you actually need to know in terms of the techniques required to simplify your rational expressions. As always, if you have any specific questions about this video, or just any question in maths that you're struggling with, you can send it to me at questions@mathematicalsupport.net, and I'll try and respond, give you a worked example, in a video response. So I hope you found this useful, and thank you for watching. Bye.